you must be defensive. That's it. By 1st of January, you supposed to be defended, and documents supposed to be in Kiev. Or otherwise, Так, once again, some days along, we been working with this diagram of coordination, which actually immediately related to Sylvan frame. Sylvan, sorry, it's don't like collaborate much, to this frame. And in this frame, we talked about what are the assembly components in common parts. We have discussed what is the sequence of assembling we are going to use. In line with this idea, what is the sequence, we were speculating and discussing about the assembly methods, literally which bases we need to use during assembling. These bases, normally, they are reflected in a document which is called locating chart. In a corner, in the left bottom corner, you see some attempts, at least in some cross-section, to show locating chart. Right now, we are not discussing this. What we did next, until we selecting assembly basis and understood that we are going to use jig, as only we realize it, we also have drawn approximately scheme of jig. Yes, Sylvan? Hello. Don't be afraid to say.
Yes, madam.
Scheme of jig. This scheme of jig you see on the right area, and immediately over the scheme of jig you see some rectangles. These rectangles actually symbolically show the composition of jig, like diagram of assembling of a jig. It's very simple. What is a diagram of assembling of the jig? Carcass, or you may call it skeleton. We may call it also frame-like, carcass or frame-like skeleton, but in order not to mix up word frame, which we're talking when we're talking about assembly unit, and word frame when we're talking about jig, I propose to call it carcass or skeleton of the jig. So in both of cases that are reflected right now in front of you at the top place of screen over the scheme of jig, it's assembly diagram of jig. Very simple, because jig is very simple. This diagram consists of carcass, it consists of locators of contour and locators of CFH. That's it. But there are two different diagrams. Why they are two different diagrams? Because you have here uh, two different approaches realized to mounting procedure of jig. We know that all the methods of coordination may be distinguished by very important, not feature, peculiarity, let it be. No? How exactly we're going to mount the jig? Either we use special means of coordination, special means for mounting the jig. Special, it means that repeating the sizes and shapes of assembly units. And literally, in this case, we're going to use method of attaching, not method, but technique, let it be, of attaching of elements of jig to this physical carrier of sizes, some imitation of real assembly unit. And this imitator of assembly unit may be flat, then it's called template, or it's maybe three-dimensional, then it's called mounting standard, or mock-up, literally. And that is very simple, seems like very simple technique of coordination, and very, in some cases, it's not very accurate when it comes about template methods and aggregates. Now, when it comes about flat unit or conditional flat unit, template technique give you the same accuracy of jig as technique was using of mockup. When it comes about simple jigs, so-called flat, on the right side of the jig, little piece that you see, it's referred to the so-called instrumental approaches for mounting the jig. What does it mean, instrumental? We're going to use universal instruments, universal tools for measuring position of elements of jig. What are these instruments, and what exactly we do? We studied in lectures, we studied in labs, and we have already some videos where I explain it, but literally each step of procedure of mounting, procedure of coordination, in detailed way. Right now, we are going to come back to these things, but I'm not going to explain much. We're going to see only how that or another technique will be reflected in diagram of coordination. Once again, you pay attention, close attention to the field of this drawing, because we're going to use with another file right now. What do we see here? If you switch on your bright minds, people, I love you, you will see here all the 5 tasks for pre-gradient. And whatever you see in this one field, in one area of this picture, you see all the unique places of your bachelor works, literally. Above the all, no, in first items, in your bachelor work, we have diagram of assembling of coordination. Next, you have so-called working materials, which include locating chart on the left here, at the bottom on the left. Part supply condition on the right, this table. Part supply condition. Next, you have, no, in the last portion of bachelor work you're explaining this, you have jig of scheme, scheme of jig, jig of scheme, scheme of jig you have. Yeah? You need to propose what is the scheme for jig. What thing is yet absent here, 2 more tasks, it's technological process of assembling, and it's absent here the text of technological process, and absent here so-called task of technical specification or technical requirements for jig designing procedure, for jig, no, to designer of jig. It describes some important moments of jig design and jig coordination techniques, in order designer may know what have decided previous engineers who have selected the diagram of assembling, who have selected bases and so on. Because jig really in real life it's created after you have all the incoming information. Incoming information is diagram of assembling, locating chart, and part supply conditions. Next, workshop technologist, workshop engineer, he's writing, she, yeah, writing the technological process, and together with technological process, it also creates so-called scheme object, something that you do in your bachelor work. Next, on the base of this scheme of jig and on the base all the previous materials plus technical requirements, some description, let it be, of jig, such an engineer create the assembly drawing, no, may create the model, of course, 3D model of jig, detailized one, and create a drawing of assembly jig. Next, yeah, with specification, at least, I mean, with specification, technical demands immediately, yeah, about it, with at least with all this detalization and so on. And then you might start, no, not work, but manufacturing of jig. And after jig is ready, you might start work in workshop with this frame. Yeah? It's like technical preparation will be finished. Once again, practically all the tasks on the example of this frame, Sylvan, we have already considered. But when it comes about tasks for grade in our pre-gradient, you have another unit. You all have to work with the same unit, panel. We even have this picture, and you need to fulfill similar tasks in order actually those things that we are considering in this video about your frame, everyone might do on its own. Remind you that you have video about summer practical training. In summer, we have practically finished the same things, but for Anna RIP. For RIP, we did it in summer. Now we do it for frame in order each of you might reproduce it in bachelor work in such a way also. Once again, first we think about sequence of assembling, top line here. Next, what we start doing? No, first, of course, we need to understand what it looks like. Before you start assemble it, first you need to imagine it. At the bottom, you see what it looks like. We spent good portion of time now to fix what do we imagine it here in a paper. No, in a paper, Next, when you thinking about the sequence of assembling, you're also thinking about basis assembly method, what is first and how you locate it, where to, either to the base of jig or to the base of another part, which already preliminary located in a jig or on workbench or whatsoever. The first thing we did after sequence of assembling is locating chart. We already understand all the methods of assembling for each part, all the bases. After this, after we understand this method of assembling, we may reflect in the diagram of assembling, we may reflect so-called elements of coordination, additional elements, besides of contour and outline, if we have outline in a part. We may add here either assembly holes or coordinate fixing holes or GPH holes or whatsoever. Yeah? After we have detailed understanding what we need before assembling, we are able to create part supply conditions, those tables with explanations how part looks like before assembling. No, I'm trying to move it in order you see what I'm talking about. That one, part supply condition. And as you already understand which part looks like, no, each part, what it looks like, which part will looks like, да? For each part, you may propose, assumed, propose, whatsoever call it, how to produce this part, where this technique of part producing is reflected. No, in order not to waste time, I copy a piece from this picture. Where is reflected the history of manufacturing of each part. Silvan, say me, where we see for each part history of manufacturing. It's not complex question. Very simple. Давай.
Coordination scheme of
Yeah, in
parts.
this coordination diagram, literally we see history of each part manufacturing, what we did yesterday, before yesterday, and so on. And once again, remind that we not trying even to invent something. We are following, let's say, to patterns, to templates of manufacturing, to not literally templates which made from loft, yeah, but to some patterns, to some schemes of manufacturing. And what we were doing first, we considered something like what part made of extruded profile or sheet. Okay, extruded profile. Next, we already understand that we have some typified diagrams for extruded profile. Part is bent, part is straight, part is, and so on. Да? And next, on the base of that extruded profile diagram of coordination, typified diagram of coordination, we write our very own. But literally, we copied the diagram of coordination that was typified diagram of coordination. We've seen it sometimes yesterday. Yesterday, I've been tricking, inventing different, even for similar parts, I have showed you some different variants of manufacturing, mostly for the purpose to show you possible variants, how they are reflected in this diagram, not because they are really necessary exactly in this frame. Yes, it's correct. It's less rational, more rational, everything was correct, but it's not compulsory to do such various things here. It was just to show you what it might looks like, and like repetition, the mother of studying, it's called, да? Literally in our language, it's called повторение, мать учения. And what we were doing yesterday, we have repeated the things that you already know. Now, something rather similar, but different because we need to talk about jig, and we will talk about some different jigs. Jig is the same, yes, but we will consider mock-up techniques of mounting the jig, and we will consider next technique with instrumental means. First, I already copied this portion of file which refer to mock-up techniques. Maybe it's not everything exactly in line. No, it's okay, quite normal. Normal. Let's look. We see that all the elements that we have done in our, sorry, I still need some maybe seconds to make up my mind to this new file. We have, no, let's say, collected all the parts to one line and next descended into assembly jig. And from assembly jig, in turn, it will come line to that place, the frame number 31. Why it's not in the middle in our case? Because we changed everything here. Something like this. But once again, pay attention that you show assembly jig in line of size transferring to the frame. And why we place it such aside in, no, like in contrary to normal way in diagram of assembling, when jig is immediately in this chain, in order we might show also the coordination of jig. That is why it looks like this. Once again, remind you, we have the common origin of information here, which consists of, no, originally, of course, it comes about theoretical information, maybe in tabular way, that is why we wrote theoretical tables, maybe in equation way, that is why we wrote mathematical models, maybe it's some equation of surface. And on the ground of this information, you create 3D model of airplane. 3D model of airplane in turn consists of 3D models of aggregates like wing, fuselage, and so on. The whole digital mock-up of airplane consists of some sub-assemblies. Next, these sub-assemblies also divided into different files, maybe even saved, doesn't matter. Uh, Finally, we have 3D model of frame, and thanks, Sylvan did it correct or not ideally correct, doesn't matter. Sylvan tried to make some 3D models, and it's visible here, something like explosion, three-dimensional view of half of his frame. Yeah? And in order to remind us that 3D model of frame literally consists of 3D models of parts. And actually, we may even rewrite this, detailize this place like 3D model of rim, 3D model of top web, and so on. But in order not to litter, not to spoil the field of drawing, we left it 3D model of frame. And next, from 3D model of frame, either we're going to do drawings and work with drawing immediately, for instance, by measuring. Or we may do what? From 3D model of frame parts itself, we may do programs for those parts manufacturing. Somewhere we have line that leads to program, and next this program controlling machine, and machine do something. In some cases, it's appeared that we need some special tooling. In case of bending, for instance, or forming, we need bending punches, stretching punches. Quite clear that stretching and bending punches, they are not included in this one frame of 3D model of frame itself. Так? And it means that we need another 3D models, and these 3D models, another 3D models, they are given with separate box here. Because it's literally another digital mockup, not of airplane, but of tooling of airplane. And usually for conveniency, we also do, as we did it in previous diagram. We maybe lost it. Да? Да, we lost it. I didn't save it. Maybe save it, but do not remember where exactly. It was, in explanation at least, it was 3D model of assembly tooling. Actually, we may mention all the tooling even in one box, like 3D model of tooling, including tooling for parts manufacturing and tooling for assembly. But we usually separate them just for our convenience a little bit. Yeah? Let's type here 3D Это такой оранжевый у нас, да, что ли такое? Это не очень яркий. 3D model of assembly tooling. Ой-ой. 3D model of assembly tooling. Guys, I need Telegram with pictures and I forgot to switch it on. Now I will start Telegram. I'm afraid computer will slow down after this for some minutes. Так. 3D model of assembly tooling. How are we going to use this 3D model of assembly tooling? Look, now once again, we are working with technique which is called mock-up technique or special means for mounting. We might say that it's mounting standard, three-dimensional, but do forgive me, there is no point in such a matter, like mounting standard in this case, because what literally, how we going to mount the jig? In another video it was shown. As Telegram it's not working right now, да? I can't show you. I will try to show it approximately. We have skeleton of jig. No, client is now also not working because Telegram started. And Telegram is, of course, happy because he have not seen me for the whole half an hour. And now he proposed me a lot of messages. Так, where is your group? Florence. Your group is here. Photos of, oh, here is. No, until it's yet a bit. Okay. Look, those who have watched this video, I hope you will recollect those pictures. First, we have on the left we have special means, on the right we have instrumental means. First, we have empty frame, and we bring no empty frame, empty skeleton, and empty carcass. We bring here template of jig. Maybe call it mockup in this case. Yes, but no point because mockup or mountain standard in this case also will be flat. That is why we are talking, we must say, or we should say that we are talking about program template method in this, what in the diagrams that we are going to talk about. Program template method. Look at this. Program template method here means that we made template. How we made template, it's another story right now. Has fallen down from heavens. We have template, we brought template to the carcass of jig, and next we are trying to hold it in some position approximately given in mounting scheme or in assembly drawing of the jig itself. How? It may be the set of some locators, for instance, that we are going to use, or it may be for first time, for very first time, it may be just some wooden bars, some pieces of thick wooden bars you're bringing and inserting between carcass of jig and template, like filling the gaps with them, and clamping template to the frame, to the skeleton of jig, to carcass of jig, in this very first position for first some minutes. Next, you mounting onto template. In template, we have what we have agreed. We have base holes or coordinate fixing holes. Either you use coordinate fixing holes which coincide with frame coordinate fixing holes, or you have very special what we wrote lilac things, like base holes on the base, on the horizontal constructing plane of the fuselage, which used not even, they are not in use during the work of jig at all. When jig is assembling frames, they are not in use, they are extra elements. What they are necessary for? To bring templates second time, fifth time, 100th time to the same place, located to the same place, as it was during the very first time. In order to inspect the jig, for instance, to inspect jig, to repair jig, you need to understand exactly where was first position of template. For this, you do special locators, but these locators, they are literally reference holes for fuse locating template again back to the same position in the jig. They are not in use during the jig life. We may mention them if you'd like. We may mention them separately as elements in diagram of coordination. Right now, we not talk about them, and we may pretend that they are uh, hidden in the diagram of coordination, like coordinate fixing holes, да? Because literally it's the same thing. Так, now what we have? We have empty skeleton, template. We have also some locators. You see, да? Locators may be just locator of contour, or it might be locator of contour combined with locator of CFH, or locator of CFH may be completely separate thing, which is what like at the bottom, да? Which will be mounted immediately to the frame. No, to the frame, to the skeleton. I permanently use wrong word. Sorry, I may mislead you occasionally. And additionally, we have agreed that we are going to use intermediate connectors, those grayish things. Grayish not interesting for us at all. We're just going to join join skeleton carcass with locators of contours or locators of CFH with such elements. In our case, they look like opened palms, no? Like hands. You see, like someone surprised it and show it. I don't know, no? And pay attention. In both in locators and in these things, there are in these connectors, no? There are mounting holes. There are holes for aligning them. But pay attention, those holes, they are not shown with red color. We are not interested in their position. Wherever they are, we are not interested. Why? Because we are interested only in aligning of contours in some contour locators and in aligning coordinate fixing holes with respect to the contour of these locators. That's it. Mounting holes are not interested for us if we have no substinator, let's say, no, of real assembly unit, which repeat all the necessary for us sizes and of shapes, holes, contours, and so on. Pay attention, it's not even similar to frame itself. It's some piece of metal or wood, flat plate, which repeat your frame only in some features. In our case, it comes about contour and it comes about some CFH holes. Let's come back to diagram of coordination. Oh, I will going to draw that as well. How we may assemble carcass. Look, we need to produce carcass somehow. How we may assemble carcass. No, I hope also you do remember. I left telegram to do it. Seems like I hope you do remember the pictures of jigs, photos. Next it was. Так, may I open one more group here? Exactly for photos. Yesterday I've seen in the group a lot of photos rather close to each other. As a previous to you group. You see, they were doing the same things and they had the same problems as you are. Так, да. Ну, let's use. I hope it's visible for you that frame of jig, those beam-like elements, да, they are assembled also. They are not the solid unit made from one piece of metal. They are assembled. What does it mean they are assembled? They are welded and rather roughly welded from pieces of standard extruded profiles. It may be T channels, it may be C channels. In our, do you see some different jigs here? And you see that they are all consist of C channels which are welded to each other, and it's something like a beam with without the middle, let it be, no? Beam with an inner cavity. And the question is, no, and also to this beam, as we agreed, to join some barrels, some places where you're going to join, where you're going to insert not locators, but connectors, да? Like all locators of CFH if you need. And also everything is roughly welded, but everything has sizes, everything somehow ordered, and the one who produced this skeleton, this carcass, he also need exact information about length, size, height, and so on. Yeah? Where such person may took such information. People, let's see. Yesterday I sent you this, where we might find information about the origins of coordination. Look, about some device. Drawing loft standard program. Да? Where people who do this rough, how do you see? How do you think? Is it, do forgive me, made, cut, weld in CNC machine, or it's something more simple? I mean, elements of skeleton. Sylvan, how
Ma'am.
do you think? Made in CNC machine, this beam-like pieces of frame, or these green things, these big blue things. Look, they are roughly welded, I said. Welded with very rough tool. Maybe it's arc welding, maybe it was even oxy-fuel welding. Certainly, it's not a program responsible for their manufacturing. Да? We understand that it's not program and not CNC machine. Yes?
Yes,
Do we
madam.
understand? But how the one who work in a shop, it's not compulsory, very experienced person, may got information about skeleton of jig, about carcass of jig, sizes and shapes. Where from? Not a program.
From drawing.
Drawing, exactly. Yes, thank you. It means that from 3D model, we are going to do drawing, да? Instead of 3D model of assembly tooling, the one who responsible to produce all those things, they do drawing in line with programs, да? Here, да, now it's red, drawing. It's called assembly drawing of assembly tooling. Да? Let's write down here. Assembly drawing of assembly jig, even, да? Of assembly jig. What? Literally, because we don't need anything else. In your case, we don't need anything else. So assembly drawing of assembly jig. Those who use them mockup, or those who have need in how it's called, mounting plate, maybe in some other things, they have more than just assembly drawing of jig. They have assembly drawing of jig, assembly drawing of mounting plate, assembly drawing of gauge must be, да? You have only assembly drawing of assembly jig. Oh, great. Assembly of. Assembly of. Uh, if you not mind, I will write it with my. I will write it just with point. Here to save space. Assembly drawing of assembly jig. Ой, все равно не влазит. Assembly drawing of assembly jig. Drawing of assembly jig. It's enough, to be frank. Так, drawing of assembly jig, and next we are not even trying to explain what we are going to use. Maybe just simple ruler, да? But skeleton, in this case, it's already ready, already assembled. And we need to come back maybe to join line here. I forget again about, I know myself. Next it appears that I forgot this line, that line, as usual. Yeah? And here we have information comes from 3D model of assembly tooling to assembly jig drawing. What is next? Once again, look, we still have to understand, sorry, jumping like a frog. We still have to understand how we are going to, not, I hope we understand how we are going to place them. I hope we understand. We are attaching it to the template, those things. Так? But we still not reflected it in our picture. We are going to use template. Where template? Which line? If we have equipment, tooling, means of coordination, origins of coordination. Template is in. Silvan, please. You're the only who may reply me, please.
Design drawings.
No. Look, templates. To find templates in a diagram, they are origin of coordination, they are means of coordination, equipment. Templates are not
Means
visible.
of coordination. Means of
No,
coordination.
means of coordination and interchangeability provided. They are means. So where we're going to draw template, we will see where the line of means, what here is now, line of means, immediately under the red line. That is why we need this red line, by the way. In order to understand where to draw. Так. Red line and, no, it's red line and it's thicker. And we have here gray line, but thinner. Yeah. So we have template. Let's draw template here in means of coordination. Somewhere here. I got to change to such a template. It has name template of jig. I hope you do remember. Template. Thank you, much helpful. Of jig. Template of jig. It's designated as TG, like this. Once again, in your diagram, you may use abbreviations, but if I were you, I would leave some creeps in the diagram field in order, no, like write with details wherever it's possible, in order when you are asked, in order when you are questioned, you're more simple to answer. Not you're more simple to answer, it's more simple for you to answer. Now, how do you think? What I need to do also here? Locator of contour. Look, locator of contour. Its appearance. It has complex shape actually. Yeah? It's appeared from nowhere. What those things? This green element, or it has some very specific and rather accurate shape. Sorry, what is it? Да что ж такое? Да, вот тут. This locator of contour. No, look, first we need template. Yes, we need to produce template somehow on one hand. Agree? How? Давай, let's come back to the template. Okay, maybe it will help you to understand what I'm asking now. Template. Look, now it has no history. Where it's appeared from? On the right, what here in the field of drawing, no, we have template in this line. Look on these templates. Template of contour, template of drilling. What their history was. How they have appeared. Oh, still one.
Tooling?
Look at them. Template of contour, template of drilling. Where they started from? Yes.
CNC milling router.
Now, CNC milling router has cut for us by our request, да, by program, not actually by our request, according to our wish, да, program and program. Да что я тут мутю? Program made for us, CNC machine made for us, да, made for us couple of templates. May we do the same here? Look, template, and do pay attention, the CNC machine in the same line, because it's also considered like element of mean of coordination. What CNC machines, they are here in instrumental means of coordination. Mhm, mhm. They considered like measuring devices. So here we're writing CNC. Oh, why I'm so stupid today? Not that I mean that I usually much more clever, but today I'm especially slow. CNC milling router. I'm already checking each step. Wrote something and watch whether it's correct or not, like some letters. No? Look, CNC milling router. And this CNC milling router, which is literally CNC milling machine of special type, it's just two-dimensional machine. It make a template. Now, Silvan, wait. We need contour locator. By its contour, it's actually the same as template. How you propose to produce this contour locator? Help me. Look, very close to this one. What? This green thing. It's just flat piece of wood or metal. If we open once again the photos of jig, not if, but when. Pay attention. You see this blue board in front, no? Do you see it?
Yes, ma'am.
That is physically contour locator, what it looks like this. By the word here is what on this place. It's locator of CFH. What on one side of the jig, on one side of the skeleton. They combine it to special jig on the same skeleton. On one side, in front of us, we have contour locator, and this locator of contour, it has some clamps. Those things, they are clamps. They are not ideally similar to what we use in our laboratory class, what you have seen in video, but rather close as for me. They are clamps which are joined to locator of contour. Look, on this locator of contour, there are some locators not for you. You don't need it. No? There are some another locators of contour. They are locators for knees. They imitate pieces of stringers, and knees would be placed, no, as we not included knees into your frame. Да? Maybe we think that they are any panel, or that we don't need them at all. Here is visible that in this frame that knees located by special locators of contour also, something like stopper. And those things that you see, rough frame, no, rough structure, let it be, with barrel at the end, and bushing with hole, it's locator of CFH. Another locator of CFH, look, aside, here is what? No? Locator of CFH. The jig that we see it like from back side, now, what this jig. Also, locator of CFH, locator of CFH, locator of CFH. It's for two different frames, but they are so similar. No, literally, they are very similar, typified jigs. Those jigs that necessary for you, look, that is the bottom, for instance, of fuselage. That something that necessary for you, maybe some another jig, next one, which is hidden, what after this I don't know. No, it's not stable. Table. It's something like bench to move up to the upper places object, and it's the same half circle or horseshoe, да, you see, but rotated to another side, and looks also very similar. You have wooden or metal plate which repeat the shape, contour of your frame, and it's joined with some clamps. It's not complex so much. You just need to get used to these ideas. It's very simple. How do you think how this uh, curvative plate, this locator, how it was produced? How do you think?
Um,
By
same,
by same as come up, come.
same as how we produce the top cap, bottom cap.
No, my dear. Top cap and bottom cap, they been made of extruded profile. Here you see something made literally of sheet, but very thick sheet. For
Okay.
instance, how you made the web? You cut it in CNC, yes? Agree?
Yes, madam.
And because it's two-dimensional, it's flat. It might be CNC milling machine or router. Давай, let's come back to the previous day. Да? Look, for this top web, which has no any bending element. Yesterday we left it on purpose like this. Да? You see, curvative part. Да? And this curvative part, it just program milling router and the part itself already. Yes?
Yes, madam.
May we do the same to this locator of contour.
No, we need to make bending.
We need what?
For locator of counter, we need to make bending, right? But top, I mean,
No,
the top
no,
plate does.
no, look at this. Why you need bending? No, take piece of plywood, no, very thick. No, which bending? Look at this. It's just piece either of metal plate or wooden plate. You see it? What's this?
Yes, ma'am.
For sure. May you
Yeah,
cut it
we
from
can,
thick
we
piece
can
of
do.
metal. May you? Sylvan, давай, let's see another jigs then. Not for the frame, maybe it will help you. Maybe. Wait a second. It's our group. No, it's not our group. Так. Сейчас. Either we will see it immediately here in photos or we will open. I need exactly photos in order you have proofs. Let it be. Look at this photo, for instance. No, maybe not clearly visible. These grayish things, what these silver-like things, да, in front, locators. No, seems like they are locators of contours. They are bent or they are just cut from piece of thick plate.
Cut from the piece of sheet plate.
Да. Look at this. Oh, no, this. No, it's just for, by the word, great thing. Not good visible, but it's for another assembly method. It's for assembly method with mockup elements. Так, photos of jigs. Look at this. It's exactly jig of panel. Да? What do you see here? Thick plates, да? Metal
Yes,
plates.
ma'am.
How maybe they done? Either use drawing, measuring, and cut it in milling machine by measuring, rather complicated technique, or you cut it by template like it was in previous years. It's reduce difficulties with measuring. Or if you anyway have programs, you may immediately do the same thing, да? In this CNC milling rotor. This CNC milling board by program. No, of course, physically it's supposed to be two different programs. If we have here milling machine or milling rotor, we write here the program. Oi, I would better steal this program instead of write it like this. We have program. No, really there are two programs. If even the same machine is working with them, there are two different programs. They are all those programs. They are from tooling. So one, you're too much overstressed, I would say, because nothing difficult. Don't think that here some trap or something complex. It's not complex. It's very simple. That is the simplest things comparatively to what we did yesterday. Maybe you're just already overtired and permanently waiting for some trick. For some trap. Not trick, trap. There are no traps any longer. Look, so you have, on one hand, you need to produce this thing. No, sorry, in order to save time, not drawing broken lines or something like this. You need to do something to me in order I'll be more attentive. You need to produce what you have CNC milling rotor, and you need to cut out preliminary these locators. You need to bring them already ready. They are already cut with ready contours. And on other side, hand, you have template of jig, this thing, да? Which you're going, what you have this preliminary, you cut this, preliminary, you cut this, you brought it to the mounting procedure, attach one to another, and you have ready jig. Look, we already brought it, manufacture it, as I said, да? Now, what we do? Now we show that next template is responsible both for this and for that. Ну, как-нибудь уже пристройте эту линию, пожалуйста. Template. Do this and that. Да? Sorry, everything is very uneven today. And so on. How do you think we finished?
Yes.
Yes, we finished. That's it. Let's compare to what I sent yesterday. Смотри, here we have two diagrams by mountain standard. Да? Pay attention, one of them for traditional techniques, old-fashioned techniques, when we had no computers, CNC, and so on, when we've been forced to use lofts. And another one with 3D models. Let's compare what is different with respect to your diagram, what is another, what is different. It has more types of locators. In your case, you don't need jigging plate, you have no GBH locators, да? You have only CFH locator and contour locator. Look, mounting standard, in your case, it's a template of jig. Mounting standard, да, and contour locator. Here I skip one more line. I forgot. Oh, just forgot. Sorry. I need to draw here CNC milling machine and combine it here with the contour locator, because contour locator it's not appeared from nowhere. No, actually, when it comes about technique of using of mounting standard, it's not compulsory. Contour locator might be produced finally by molding from mounting standard. So in our case, we have decided that we already made locator of contour in CNC. We also made template in this yellow thing, CNC. CNC was controlled by program. Program have started from 3D model of assembly jig, 3D model of чего-то там, some another. Actually, those diagrams, they are being used as explanation to pre-graduate class. Now that is why it's mentioned here, the scheme. And Look, in general, when it's little, it's very good visible. Whatever you did, now you have some mockup or template here, and all the elements of templates, all the elements of jig, they are joined to the template. It means they attach it. They took information from template. Now, if I reduce it, like this, I hope it's may you help you to concentrate your sight onto this heart of picture in the center of picture. Да? Everything is joined to this mountain standard or template besides of skeleton. Skeleton, of course, it's supposed to have relation to drawing. Да? And tooling drawing should be a little bit higher, not here. Так, уважаемый. Дальше. So here we did everything. Yes? Let's save it. One more thing that should be here also, because usually committee, they like to ask about. Now file is saved and we will, так, and we will, file saved. And we will add here in structure object beta to satisfy committee, to make them happy. No, bind is not replying again. No, it's replying already. Add one more element here. Lamp. Lamps are standard parts. No need to show there no, additionally any things. You may just hang them, those lamps, like так, no? Lamps. In case someone asks, we might say that, of course, better to show it like they are related to drawing of assembly jig. Information about of clamps is given in assembly jig. So we might show what those things like and related to clamps, but usually we not even do it. Just clamps and forget about. Next, here also in this line where you have all the parts, committee usually likes when students don't forget so-called standard items and fasteners. No, I would type here fasteners. Idea is that you have rivets, bolts, maybe washers, maybe something else, and those things. They are mentioned in the diagram of coordination, but no, seems like they have no history. Why? We not produce them. We are not going to coordinate them. We're just buying ready items. We don't know what was the history at the bottom. We bought them. We are going to use them, but we bought them. Now, let's save this as Sylvan 4. Z1 Sylvan program template method. Once again, remind you why program template. Program because we literally are relying upon programs. And why template? Because we use template for mounting the jig. Template is our mean of coordination in this game. And actually, I don't know what it's asking about. Seems like it's pretending the great processor which has layers or something like this. Transparency will be lost if you save it. It was transparent, you see, before. And pay attention. What did I say before? So on. When computer interrupted me, what I was explaining you? Let's forget about. Why are you so silent? You're also scared. I hope I recollected. I said it's program template method. What we are going to do right now, we will save file as program instrumental method. Program instrumental method, and we are going to until it's saved. Yet it's saved. Sylvan, watch me attentively. What we are going to do? Oh, what a pain! I killed everything. You see? What for? To make Sylvan cry. Sylvan, do you hear me?
Yes, ma'am, I can hear you, madam.
Look at this. What for I have deleted this diagram? Because we are going to repeat again, but I hope it takes us less time, now. But we are going to repeat it for another approach. If we come back to Telegram here, to your group, I hope you do remember these pictures that I have already sometimes shown it. We might do something by attaching what here is on the left, you have attaching technique. And what is the difference in this attaching technique? We don't measure position of mounting holes, neither in skeleton nor in locators. We do all the jig using attaching to some carrier of sizes like template or mockup. On the right, you have another technique, another approach to coordination. This another approach to coordination, they are usually called instrumental methods because we are measuring positions with instruments. Normally, it comes about measuring of instrument of mounting holes, but now you see the technique of mounting is a bit different. The same skeleton, but it's already preliminary joined with connectors. In previous case, connectors been flying, no, not this here. They are hanging in the air, before mounting, and I said we are not interested where these holes are. In instrumental techniques, they are preliminary joined with skeleton or jig and joined in such a way that their coordinates, which are given in the special drawing, in a drawing of assembly jig, their coordinates, they all, it's called coordinated, they are all in the proper places. And when, not if, but when you hang, you just hang with respective holes, locators to such a frame, to such a skeleton, the system of locators inside give you the proper contour and proper position of coordinate fixing holes. All the things preliminary measured. How exactly they are measured? Do recollect that one, it might be measured by instrumental stand or universal coordinate measuring table. This dreadful thing with I've seen this dreadful thing. Something like this. No? It's universal coordinate measuring table and principle of using of such devices are shown not in pictures, for instance. So we're really measuring sizes and next we're just hanging things like this to each other. How to reflect it in diagram of coordination? First, let's place here the same assembly jig. Let's place it. Now, look, I said mounting holes we need preliminary to measure. Very well. But it means that we need to insert there some measuring device. But where mounting holes are already shown, where they are shown in drawing of assembly jig. So seems like you just need to join. Seems like you don't need to change tool, madam. Seems like you need to join here mounting hole to the drawing of assembly jig. Problem is solved, but we need to understand measuring device and where to place this measuring device. Once again, what is our measuring device? Those things, universal coordinate measuring tables, or it may be its variation, like loft conductor or instrumental stand. I recommend to use either this universal coordinate measuring table or instrumental stand. Let's check where this device is in our diagram. Look, search it. UCMT, instrumental stand, load conductor, all the measuring devices, likewise templates and mockups, they are semi.
Means of coordination.
Exactly. Means of coordination. So means of coordination, I hope you remember under the red line. Now, what immediately. Means of coordination, templates, CNC machines, everything that we consider like mean of coordination, we place it somewhere here. Tick, 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 tick. I'm already boiling literally because of my stupidity, my own stupidity today. If you not mind, I will write here UKMC, and I'm going to write it in very long way, like this, because I do it with record. Now, universal in order everyone else might say, ой, universal. Universal. Что вы пишете? Universal coordinate measuring table. UCMT. Like this. Да? Universal coordinate measuring table, or abbreviation is UCMT. Or instrumental stand. Да? Or maybe instrumental stand. No, instrumental stand, it's too complicated device. Universal coordinate measuring table. It has additional engine, it's very big and so on. For such little frame, UCMT, it's enough. Так, universal coordinate measuring table, and it's responsible for these mounting holes. Locators of CFH, actually, they are ready bushings, as you have seen. How to understand where they supposed to be placed? They are standard bushings, which you insert into the standard barrels in the frame. Where to place, how to understand where they are. They are also in coordinates. You do remember, I hope, in your drawings, there are coordinates of coordinate holes, coordinate fixing holes, CFH, in a frame. In drawing of assembly jig, also you show locators of CFH with coordinates that you are going to measure and how you're going to measure. So, what is measuring device for us?
Universal measure.
Yes,
Universal
yes.
coordinate measuring table.
Да. So, one more line, to this place. What about these locators of contours? No, in contrary to previous scheme, where we had line of manufacturing and line of locating. Locating will be due to aligning holes, this mounting hole and this mounting hole. So we don't need already special mean here for mounting procedure. We're not mentioning. We just need to produce it. How we have produced this locator previous time? Remind me. Oh, I should remind you.
CNC milling machine.
Да, exactly. It was same similar rotor here, in means of coordination. Так, так. Silvan, we almost finished. I understand that you're tired, but we almost finished. Don't worry. CNC milling rotor made for you. Давай, наверное, даже вот так немножко сдвинемся. CNC milling rotor made by program, да? By programs it started from origin of coordination in the view of origin of information, sorry. Origin information in the view of the 3D model of assembly tooling. Router responsible for this. And how do you think? Do we finish? Have we finished or not?
Yes, ma'am. Finished.
Yes, exactly. We finished. That's it. It's not difficult, really. And no, at least for your jig, it's not much complex jig. Don't so worry that something dreadful happened in your life now. Так, let's just to satisfy committee, to make us happy, all, I mean, all your teachers. And we have finished. Let me to remind. No, I mean, meant to show you one more diagram. Look, here is, seems like set of similar pictures, no? Mounting of jig and reminding also about this composition lines. And here you see, look, instrumental stand, lost conductor, template of jig. Here is too much complicated jig, as I said you. It includes all the possible kinds of locators. This is why too much elements. In your case, you don't need this one, you don't need this one. No? And in your case, you don't need the mounting plates, master plates, gauges. You don't need it because your jig is very simple. If you exclude all these elements, that is traditional technique, what you have seen right now with lofts, with templates. That is newish technique. What here is new technique with CNC milling machine, program, and instrumental staff. And if you exclude unnecessary elements, jigging plate, GBH locator, gauge, mounting plate, master plate, you don't need it. Yeah? If value excluded, what you have got? This one. Look, exactly what you have already in your drawing. No, in your diagrams that we did right now. When you compare this after class, compare these bright pictures with what you have, I mean, what we have constructed right now, literally constructed. And you will see that it's very similar. Now, what I'd like to do, I'd like to compare visually a couple of files for a minute, and we will finish and we will interrupt the record. Так, first, remind you, it comes about frame, and different variants of co-ordination of jig. Path coordination, it's another story. We finished it yesterday, and path coordination, depending on that or another manufacturing history, techniques of manufacturing of path, we applied that to another story of coordination, let it be also. But in general, we have followed the rule that we have everything in digital mockup, all the information, our origin of information, they are relied upon in digital mockup. And whatever we do, we try to use modern machines. No, besides of the fact that somewhere I proposed you to use complicated, seems like complicated diagram, but in real life, those things, those tricks, they are necessary to save money. In case you are working with primitive parts, it's too much, we are too much greedy to use CNC machines to cut a couple of lines, for instance. It's too much. If possible, to use primitive equipment, you need template and primitive equipment. CNC machine you use once to produce template, and next during 5 years you are using primitive equipment. You are not paying a lot of money, the whole fortune, for CNC machines in order to cut some piece of sheet along a couple of lines. Yeah? And wherever it's possible, we're using CNC If we're talking about complex things to cut, like contours of rim, finally we are cutting in CNC machine. Yeah? Here. Yeah? What we left here, the top web cut in CNC milling router, actually it was made for example, just for instance. Yeah? And mostly we're talking about to produce tooling in CNC machines, and wherever it's possible, we could use the simple equipment, primitive one. So it was program method of coordination. By its origin of coordination, mostly it was program. Yes, because wherever we are watching, it was program, 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 program. Next, what is mean of coordination? In our case, as mean of coordination, we used either instrumental means, like CNC machines, or template means when we produce parts. So we might say that we use program template, program instrumental method when it comes about parts. When it comes about jig, what we did with you? Once we did, no, let's close this file in order computer feel free, let's say. And let's open the file that was previously, no, here. Assembly jig. Mount. Вот Slovan 2, Slovan 3. О, Slovan PRTM, Slovan PRM. Let's open PRTM, да? When it comes about jig, it's appeared that in both of cases, да, paths were not discussing the program tooling method, program template method, program instrumental method. Pay your attention. We did two different diagram of coordination today. Так, file is yet opening, you understand. No, seems like we made two different diagrams of coordination. We constructed two different diagrams of coordination, but when not touched any piece of left portion when it comes about parts manufacturing. We worked only in right portion of the diagram where it comes about the jig. And what we did in this portion of diagram, we had the same set of locators and clamps, skeleton carcass, locators, and clamps. At the bottom, we had the same 3D model of tooling, and depending what we have chosen to produce template and attach everything to the template, it's program template method, or to measure position of jig elements, да, we have developed two different diagrams of coordination. So I'm about to cry. File is opening, of course, but it's opening so slowly. No, you see. Once again. Oh, the great. It's done. It's done, but in another program. That is why it's done. Like this. It's program for viewing, but not for editing. That is why it's more simple to open. You see, no? Diagrams mostly very similar. The difference only in some places, but literally in couple of places here, no? In the left. Even in the left portion, it's very similar. Assembly tooling, 3D model. Assembly drawing of tooling, no, of assembly jig, assembly drawing of assembly jig. In one case, we are not interested in pole positions at the bottom. We are not measuring anything. No? In top case, program instrumental method, we have included measuring device intermediate coordination. You can this you see in MT, UKMS, Universal Coordinate Measuring Table. And in both of cases, CNC milling router we use to produce locator itself. That's it. You have seen practically everything already.